Okay, so today we want to look at the root to this radical equation. I saw this radical equation some time ago, and I published the video, but one of the viewers said I have to make a video to prove the roots that the roots are not actually correct. In that video, I said that out of the three roots, this root is rejected, and also this root is also rejected. That the only root that will satisfy this equation is the number 2, okay? Because in this radical equation, there are no real roots, okay? So we only have imaginary root that can satisfy this. So we want to make a check. We want to do a check on this to know if this root is actually correct. That is the essence of this video. So if you're new to this channel, kindly subscribe, and when you subscribe, turn on the bell notification button so that you get notified whenever we drop a wonderful video like the one you about to watch now. Now, I'm not going to solving this equation again, okay? The video is showing up there now, okay? You can watch the video there, okay? It's showing up there. Just click on that link. There you will get the solution to how we came about these three roots here now. So we want to check root number 1, if it will satisfy the equation, root number 2, and root number 3, if they will satisfy this equation. So we're taking root number 1 when x is equal to your positive 1. Okay, so we take when x is equal to 1. Let's bring down the equation, which is x root your x plus 1 equal to 0. Sorry, is equal to 0. Good. So it means that whenever we see x, let's put in 1 in there. And so the first one we're going to have here, 1, so the square root of 1 plus 1 equal to 0. The square root of 1 is 1. And so we have this to be 1 times 1 plus 1 equal to 0. So we have 1 plus 1 equal to 0. 1 plus 1 will give us 2. So 2 is not equal to 0. So this shows that the first root, x equal to 1, will not satisfy this equation. Hence, it is rejected. Okay, so we reject this root here. This one is rejected. Okay, so let's go to root number 2, which is x equal to 1 all over 2, bracket open, iota, square root of 3 minus 1. Let's check with this and see if it will satisfy our equation. All right, so let's rule of this. Okay, so we take our equation again, which is your x root x plus 1 equals to 0. Okay, so let's put the whole of this into this equation. So this will give us 1 all over 2, bracket, open, iota, root 3, then minus 1. This is 1, then close bracket. Then here we have square root of your 1 all over 2, bracket, iota of 3, then square root of 3, then minus 1, close bracket, plus 1 equal to 0. What we do here? Now, from here, send this one to this other side. So we're going to have this to be 1 all over 2, bracket, your iota of square root of 3, minus 1, close bracket, then into the square root of your 1 all over 2 bracket iota square root of 3 minus 1, okay, then close bracket, equal to minus 1. We want to take care of this radical, so let's square both sides of the equation. If we do that, we are going to square this. At the same time, we are going to square this, and at the same time, we square this. Okay, then this radical, this square will go with this radical. And so here we are now left with your 1 all over, okay. Now, this square is covering everything here, please. Okay, let me rewrite this. This square is covering everything here. Okay, so here we are now having this square. So we can express this out as our 1 all over 2, bracket, your iota, square root of 3 minus 1, close bracket, then dot, your 1 all over 2, bracket, your iota, square root of 3 minus 1, close bracket. That's for this. Then here, dot, your 1 all over 2, which is what we have here now. Bracket, your iota, square root of 3 minus 1, close bracket, equal to The square root of minus 1 is 1. Now, what we do now, we want to use this first to open up this. So, if we are to handle this first, we have to use this to multiply this. We use this also to multiply this. While we use this minus 1 to multiply this, and also use it to multiply this. So, if we go by the arrow movement, let's bring out this 1 all over 2 and this 1 all over 2. So, we have 1 all over your 4. Okay, because this is multiplication. So here bracket I root 3 times your I root 3 will give us your I squared root 9. Okay, this is 9, please. Root 9. Then your I root 3 times minus 1 will give us minus your I root 3. Then we come to this minus 1. Minus 1 times your I root 3 will give us here minus your I root 3. Then minus 1 times minus 1 will give us plus 1. Okay, close bracket. Meanwhile, we still have this on this other side. And so we have here dot 1 all over 2 bracket your I root 3 minus 1 close bracket equal to positive 1. Good. Now, what is your I squared? I squared is minus 1. So here we have 1 all over 4 bracket minus 1, and the square root of 9 will give us 3. So minus 1 times 3 will give us minus 3. Then here we have I root 3 minus I root 3. This will give us minus 2I root 3. Then plus 1. Close bracket, dot 1 all over 2, bracket your I root 3 minus 1. Everything equal to 1. Easy. Again, we look at this again. So from here, we are having minus 3 plus 1. That will give us minus 2. And so this will now give us here your 1 all over 4, bracket minus 2 minus your 2 root your I root 3, okay, close bracket, dot 1 all over your 2 bracket your iota root 3 minus 1 are equal to 1. So yeah, we have 2 is common here. So if we factor out 2, dividing your 4 here, then it will give us 1 all over 2. And so we are going to have this to be 1 all over 2 bracket your minus 1, then minus your I root 3, close bracket, into dot your 1 all over 2, then bracket your I root 3 minus 1, close bracket, equal to 1. So again, we use this to open up this. So if we do that, we bring out this and this out first. So this will give us here 1 all over 4 bracket minus 1 times your I root 3 will give us minus your iota root 3. Then minus 1 times minus 1 will give us plus 1. We come to this side, minus I root 3 times plus I root 3 will give us minus I squared root your 9. Then minus I root 3 times minus 1 will give us plus your I root 3. Okay, close bracket, everything equal to 1. Again, this we go with this. Okay, so here we are now left with your 1 all over 4 into, here we have 1, which is for this. So here we have minus 1 times your square root of 9 is 3. So automatically we're going to have here 1 minus minus 3. So this will give us 1 minus bracket minus 3, close bracket, this bracket here equal to your 1. All right, so let's continue on this other side. So if we continue on this other side, look at what we have here now. So here, minus times minus will give us plus. So here we are now left with, or this now implies that your 1 all over 4 into your 1 plus 3 equal to 1. So we have 1 all over 4, then times 1 plus 3 will give us what? 4 all over 1 equal to 1. So 4 cancel 4. So we are left with 1 all over 1. So yeah, we have 1, 1. So 1 all over 1 will give us what? 1. So we now have 1 equal to 1. The solution, how to solve this radical equation to arrive at these 3 roots here now, is already solved and it's showing up here. Okay, you can watch that video later to see how we arrive at x1, x2, and x3. Okay, now we'll be able to show that x1 will not satisfy the equation, so it's rejected. S2 is the only one that will satisfy this equation, and your x3 will not satisfy this equation too. Okay, you can follow this same procedure which I have applied here now to check for your x3 if it will satisfy it, but I've done that already and it does not satisfy the equation. Okay, so this is all I have for you for today. Again, this is Online Maths TV and my name is Jakes Anemo. If you love what is going on here, give the video a thumbs up. Okay, don't forget to share this video with those that need this knowledge. Remember, I love you because I'm your friend. Now, to some persons that have actually dropped some questions in the comment section, yeah, I'm working on them, and between now and on Saturday, they will be released. Okay, thanks. We love you, we love you, we love you. We are proud of you. Remember, Jakes loves you, and everyone of us at Online Maths TV love you.